Muhammad decides to track the number of leaves on the tree in his backyard each year. The first year, there were 500 leaves. Each year thereafter, the number of leaves was 40% more than the year before. Let n be a positive integer, and let f of n denote the number of leaves on the tree in Muhammad's backyard in the nth year since he started tracking it. The expression f of n defines a sequence. What kind of sequence is f of n? So some of you might be able to think about this in your head. Each successive year we're growing by 40%. That's the same thing as multiplying by 1.4. You might say, well, each successive term we're multiplying or dividing by the same number. Well, it's going to be geometric. But let's make that a little bit more tangible, just in case. So let's make a little table here. So table. So this is n, and this is f of n. So when n is equal to 1, the first year, n equals 1, there were 500 leaves. F of n is 500. Now when n is equal to 2, we're going to grow by 40%, which is the same thing as multiplying by 1.4. So 500 times 1.4, let's see, 40% of 500 is 200, so we're going to grow by 200. So we're going to go to 700. Then in year 3, we're going to grow by 40% of 700, which is 280. So it's going to grow to 980. So notice, it's definitely not an arithmetic. It's definitely not an arithmetic sequence. An arithmetic sequence, we would be adding or subtracting the same amount every time, but we're not. Here, from 500 to 700, we grew by 200, and then from 700 to 980, we grew by 280. Instead, we're multiplying or dividing by the same amount each time. In this case, we're multiplying by 1.4 each time. So we are clearly geometric. Depending on your answer to the question above, the recursive definition of the sequence can have one of the following two forms. Well, this is the arithmetic form, which we know isn't the case, so it's going to be in the geometric form. And then they ask us, what are the values of the parameters a and b for the sequence? So we have our base case here. F of n is going to be equal to a when n is equal to 1. Well, we know that when n equals 1, we had 500 leaves on the tree. So this a over here is 500. So a is 500. And then if we're not in the base case, for any other year, we're going to have, let's see, it's going to be the previous year times what? Well, it's going to be the previous year grown by 40%. To grow by 40%, you're going to multiply by 1.4. So b is going to be 1.4. You take the previous year and you multiply by 1.4 for any year other than n equals 1. So b is equal to 1.4, and we're done. Let's do another example. This is strangely fun. All right. So this says, Siu Yun hosted a party. She had 50 party favors to give away, and she gave away 3 party favors to each of her guests as they arrived at the party. Let n be a positive integer, and let g of n denote the number of party favors Siu Yun had before the nth guest arrived. All right, actually, before I even look at these questions, let me make a table here, because they're saying before the nth guest. I want to make sure I'm understanding this properly. So this is n, and then this is going to be g of n right over here. So when n is equal to 1, g of n is going to be, or g of 1 is going to be the number of party favors Siu Yun had before the first guest. Well, before the first guest, she had 50 party favors. Now the second guest comes. Now the number of party favors she had before the second guest, well, she had to give 3 to the first guest, so she's now going to have 47 party favors. Now when n is equal to 3, how many party favors did she have before the third guest? Well, she would have had to give party favors to the first and second guests, who each got 3. So she would have 44. And I think you see the pattern. For every time when n equals 1, g of n is 50, and every time we increase n by 1, every time we increment n, we are increasing g of n by minus 3, I should say, because she's giving away party favors. Minus 3. So because the difference between successive terms is the same, we know this is an arithmetic sequence. And then they say write an explicit formula for the sequence. So let's think about this. Let's see, g of n is going to be equal to, so let's see, we're going to start at 50, and we're going to subtract 3. And let's think, do we subtract 3 times n, or is it, let's see. For the first guess, we subtract 3 0 times. For the second guess, we subtract 3 once. For the third guess, we subtract 3 twice. So for the nth guess, we're going to subtract 3 n minus 1 times. Notice, for the nth guess, we subtracted 3 twice. The second guess, subtracted 3 once. First guess, subtracted 3 0 times. So this works out. For the first guess, we would subtract 3 0 times. And so g of 1 would be 50. We can see that this is consistent for all of these. So I could write 50 minus 3 times n minus 1. And I really recommend making the table here, just so you make sure you get the n minus 1 or the n right, and it all gels.